In this next section, we're going to look at direct proportionality, and it's the simplest of the linear relationships between two variables. One is equal to a constant times the other. So they go through and talk about sales tax and an equation that could represent that. What's key, though, is the way that we write up the equation, I think. And we can see this. In this case, we say that t, so that was my letter on the left, is, that's my equals, directly proportional. That's my slope. And in this section, especially when we talk about constant or proportion or directly proportional, we use the letter K rather than M. And our K happened to be a slope of 0.06 to P. And then we multiply it by P. Sometimes it's read T varies directly with P. So varies directly or directly proportional is our key there that we're going to be using the letter K. These graphs all pass through the point 0, because if you look at this, the slope is 0.06 and we don't have our B value. You know, when we do the y equals mx plus b, our b is 0. So all of our equations here are going to pass through the origin. So for this one, the number of calories C, so I'm going to start with C, is directly proportional, that's my K, to the number of ounces X. All right. They give me a little bit more information here. 1 ounce contains approximately 75 calories. We have an equation C as a function of X, but we need to find K. So to find K, we're going to use this information here. So we have 1 ounce and 75 calories. So the 75 goes in for C. The K is what we're looking for, our slope, and our X is 1. So K times 1 is K. K is going to equal 75. So my equation, plug that 75 back in there, is C equals 75 times X. That's my final answer. That's my C as a function of X. Then using that, we're going to come down here to part B and C to answer the next few questions. So how many calories are there in a quarter pounder? 4 ounces of hamburger. So we go to C equals 75 times 4, and you come up with 300, and then the units on that, calories. Again, make sure you unit label, especially on your homework. For part C, if the amount of ground beef is doubled, how does the number of calories change? Wouldn't it be great if the number of calories wasn't as much, but not so with calories. If I double the amount of ounces, so let's just do that. We started out with 4. So if I double 4 ounces, I'm going to make it 8 ounces. So then guess what happens to your calorie count? That now becomes 600 calories. So that's just an example. So to answer this question, how does the number of calories change? Calories are going to double as well. All right, and then for example 13, kind of the same idea. You're going through, you're going to set up an equation for the situation first, then answer it. So we're starting out with E, earnings, R, that's a is word, that's an equals, directly proportional, that's my K. Anytime I see that word proportional in there, I'm thinking K, to time T. Right, then they're going to give me information in this next part here to solve for the constant of proportionality, or my K value. So I plug in the E is 46, the T is 2, and this is multiplication, so to unhook it, you divide. and get k equals 23. All right, so you're going to take your 23 back up here to find the equation. E equals 23t. Use that equation to solve the problem. So the question is really, how long has a person worked? So we're looking for t if she earned $471.50. So the E is what I'm plugging in this time, 471.50 equals 23 times t. Divide both sides by 23. And it should come up to 20.5. And then the time, remember, was in hours. So that's what our unit label will be.